Hello, my name is METİN Arıdaşır. This is 151st part of explanation of my theory. I predicted multielectron boron atoms spectral lines Wholly&Certainly. Here, I hope you see. Right side, NIST measurement data. NIST National Institute of Standards and Technology Physical Measurement Laboratory. Right side, the source, data source. Left side, here, according to my theory and my formulas, I computed. Yes. Yesterday, I computed. I advise you to line by line notice. Here, 4 to 10, n number, wave number. N is one wave number. N is equal to 4, n is equal to 10. From 4th to 10th, from 4th to 7th, from 5th to 13th, etc. This is first line, experimental, and this is my prediction, experimental measurement. My prediction, experimental measurement. I advise you to notice wholly. I hope you see. Then it goes on like this. Here, left side, my computing, right side, NIST data. I advise you to notice line by line. I hope you see completely. Yes. My computation, measurements data. My computation, measurements. My computation, measurements. My computation, measurements. Like this. You see, I guess. Yes. Quantum physics, Schrodinger's wave equations, electron configuration formulas cannot do this. These are exact figures. Here, determinism. Here, certainty. There is no probabilistic waves. There is no uncertainty principle. Here, my theory here is boron. It has 5 protons and 5 electrons. Here, data from Wikipedia. Boron. 5 ionization energies. First, second, third, fourth, and fifth. Remember, I have formulas that can predict all in all atoms highest ionization energy and corresponding smallest electrons wavelength. Okay. Here. Lambda smallest, here lambda smallest boron is, I have computed 3.643 nanometer approximately. This is my formula. This is my highest ionization energy formula. I advise you watching my previous video immediately. Yes, for understanding, and I advise you to watching my former videos. Yes. All of these figures I have computed relates to smallest borons, smallest electron motion forms wavelength, 3.643. If you don't know this, you cannot manage, you cannot do these computations. And any theory, here there is no theory that can compute these figures. Quantum physics, Schrödinger equations, and then derived equations cannot do this, cannot find exact figures, never and never, because they are wrong. Here, according to accepted physics, firstly, electrons are point particles, and electrons are dimensionless particles according to accepted physics theories, and there are probabilistic waves, and there is uncertainty. No, all of atoms, all of electron motion forms are in their, say, undisturbed states, or say, ground states. All electrons positions, all electrons situations, all electrons positionings are certain according to my theory and my formulas. Here, say lithium. Here, say boron. 1, 2. Here, 1 proton. 1 proton, 2 protons. 1 proton, second proton, third proton. I add fourth, 1 proton, second proton, first proton, second proton, entangled protons, third proton, fourth proton, here fifth, 1 proton, this is arrow, second proton, down arrow, third proton, up arrow, fourth proton, down arrow, fifth proton, up arrow, and each one, here, where is boron? Each ionization energies corresponds a different wavelength size electron motion form. This is last one, smallest electron, like this, Where is it? 3.640 Okay, here, say upside. First proton. I'm so sorry. First electron here. And its wavelength, smallest wavelength, is 3.604, say. And second, different here upside, say. Then I computed 4.779, second bigger one. Here, okay, this is first one, this is second one, downside, different wavelength. What? The corresponding ionization energy, 4.700, say, 4.700 nanometer. And then $130.700, bigger one. Okay. Third conjunction, 130 point etc. nanometer. Then 197, bigger one, another conjunction, 197, then 597, greatest electron, 597, okay, here, intertwined electrons, and each electrons, first, second, third, each electrons per each proton. There is each electron per each proton, okay? And for each proton, different size electrons. When they connected protons, they reshaped, resized, they changed their wavelengths. And certainly I can predict smallest wavelength of smallest electrons corresponding highest ionization energy of an electron in an atom. And by doing this, I can predict that. I can predict. How can I predict? How can I predict? Like this, say. Like this. Wait a moment. Smallest electron's wavelength is 3.64 nanometer in boron. Okay, this is now 3 point here. And in an atom, electron motion forms are cycling in their undisturbed position, in balance position, say ground state cycling. But when from outer space successive waves of free electron motion forms affect these proton-bounded electrons, smallest electron motion forms in an atom, say fourth successive waves of free electron motion form come in, then it may enlarge this, say, smallest electron wave number squared at the rate of wave number squared. Okay, if n is equal to 4, say, n squared multiplied by n squared. Okay, 4 squared is 16 multiplied by smallest electron motion forms 3.64 for boron, for instance. And then compute 10th wave number coming here, successive wave, and vanish again and stay another 4th step from 10 to 4. Okay, what we will do, this is my formula, energy formula. Remember, HC divided by n square lambda, n square, okay, minus delta lambda cosine alpha. Here first number, here no relocating electron motion form, no delta lambda now, okay. Here, then this is my one of my main energy formula, and is wave number lambda, electron motion forms wavelength. Now what we will do, we will do HC divided by 4 square multiplied by 3.64 minus HC divided by 10 square multiplied by 3.64 is equal to, here, like this. Okay? Then we find 16.387, so forth. Go like this, in same way. We can compute it, we can determine line by line. Okay, for all atoms, my theorem, my formulas are valid. Yes, I advise you to again and again watching my former videos, because this is new theory and these are new formulas that I put forth. Have a good evening. See you later.